A venturimeter has its axis vertical, the inlet and throat diameters being 150 mm and 80 mm respectively. The throat is 220 mm above inlet and the coefficient of discharge is 0.96. Petrol of specific gravity 0.78 flows up through the venturimeter at a rate of 0.029 meter cube per second. Find the pressure head or pressure difference between the inlet and the throat. Okay, so there is a vertical venturimeter, and so this is, let us consider a rough diagram of vertical venturimeter. Okay, so this is inlet section 1, and throat section 2. So here this is called throat and this is inlet. Okay, so here inlet is datum line. Okay, so here Z1 is equals to 0. Okay, and what about Z2? So he clearly mentioned throat is 220 mm above the inlet. So Z2 is equal to 220 mm. Z2 is equal to 220 mm. Okay. So first given data. Let us write given data first. Given data. Okay. So inlet diameter. You given inlet diameter. Inlet diameter D1 is equal to how much? D1 is equals to 150 mm. 150 mm. Let us convert it into meters. 150 mm means 1 mm is equal to 10 to the power of minus 3 meters. So D1 is equal to 0.15 meters. This is value of D1 in meters. Next given throat diameter. Throat diameter D2. D2 is equals to how much? 80 mm. So again convert it into meters. 80 into 10 to the power of minus 3 meters is equal to 0.08 meters. 0.08 meters. Okay. So, and also given coefficient of discharge denoted by CD is equal to how much? 0.96. And a petrol of specific gravity 0.78 flows through this venturimeter. So specific gravity of petrol is given. Specific gravity of petrol. Let us say SP is equals to how much? 0.78. Let us find density of petrol. How to find density of petrol? Rho P. Density of petrol is equals to specific gravity of petrol into density of water or density of standard fluid. So 0.78 into density of water how much? 1000. Okay, kg per meter cube. So you will get 780 kg per meter cube. This is density of petrol. Still, given information Z1 is equals to 0 datum line and Z2 is equals to 220 mm millimeters. Let us convert into meters. So 220 into 10 to the power of minus 3 meters. You will get Z2 is equals to 0.22 meters. 0.22 meters. Is there any other information? Yes, of course, given discharge. So discharge through venturimeter. Discharge. Okay, na? Q is equal to 0.029 meter cube per second. So anyhow, what we need to find in this question? In this question, we have to find pressure difference between inlet and throat. So P1 minus P2 is equal to how much? This is our question. At last, we have to find P1 minus P2 is equal to, okay, na, difference between pressure difference between inlet and throat. Okay, na? So pressure at inlet is P1, at throat P2. We need difference P1 minus P2. Let us find. So before finding pressure difference P1 minus P2, what is the formula for discharge? Discharge through venturimeter. Q is equal to CD into A1 A2 root over 2GH by root over A1 square minus A2 square. Okay na? So discharge through Venturimeter is given by CD into A1 A2 root over 2GH by root over A1 square minus A2 square. Okay. Let us substitute all values in this formula. Okay na? Here only unknown is what? H, because G means acceleration due to gravity. G is equal to 9.81 meter per second square. So here only unknown is H. So what is H? H means difference of pressure head. Difference of pressure head. What is difference of pressure head? What is the formula for difference of pressure head? H is equals to difference of pressure head P1 by rho G plus Z1 minus P2 by rho G plus Z2. So anyhow, here flowing fluid is petrol, so we can take rho P. Rho P means density of petrol. Okay. So now H is equals to, it can be written as P1 by rho P into G minus here P2 by rho P into G plus Z1 minus Z2. Okay. So if you see first two terms, denominators are same. So rho Pg, common denominator rho Pg, P1 minus P2 plus Z1 minus Z2. Z1 minus Z2. Okay. So at last we can use this formula to find P1 minus P2. Difference between pressure difference between inlet and outlet. So here what is the unknown? H is our unknown. Okay. If you find H, then we can find P1 minus P2 because rho P is already given and we have G acceleration due to gravity Z1 and Z2. Okay. So first let us find H using discharge formula. So here A1 and A2. So A1 means inlet area. Okay. So inlet area formula A1 is equals to pi by 4 into D1 square. So pi by 4 into D1. So D1 how much? Inlet diameter 0.15 meters, so whole square. So if you calculate, you will get around 0.0177 meters square. So this is inlet area. And what about A2? A2 means throat area. Throat area. So again throat area formula A2 is equal to pi by 4 into D2 square. So pi by 4 into D2. So D2 means throat diameter. So throat diameter 0.08 whole square meter. Okay. So 0.08 meters. So whole square. D2 square whole square. Okay. Then its value is approximately 0.005 meters square. Now let us substitute all values in discharge formula. Then we can find difference of pressure head. H we can find H. So Q value 0.029 is equal to CD 0.96 into A1 0.0177 into A2 0.005 root over 2GH, 2 into acceleration due to gravity 9.81 into H whole divided by root over A1 whole square. A1 means 0.0177 whole square minus A2 square 0.005 whole square. Okay. Let us calculate. Let us simplify further. 0.029 is equal to, if you multiply 0.96, 0.0177 and 0.005, you will get approximately 8.496 into 10 to the power of minus 5 into root over 2 into 9.81 19.62 into H whole divided by square root of this expression is 0.01698. Okay, 0.029 is equal to, if you calculate 8.496 into 10 to the power minus 6 by 0.01698, you will get around 0.005 into root over 19.62H. Okay. So 0.029 is equal to 0.005 root over 19.62 into h. Okay, now transfer 0.005. Multiplication becomes division by 0.005 into h. Apply squaring on both sides. Okay, now we need h value. To eliminate square root, we should apply squaring on both sides. So, okay, so it becomes 0.029 by 0.005 whole square. Square root get cancelled. You will get 19.62 into h. So 0.029 by 0.005 value is 5.8. Whole square is equals to 19.62 into h. So 5.8 whole square means 33.64 is equals to 19.62 into h. Now transpose this 19.62. It becomes 33.64 divided by 19.62 is equals to h. So 33.64 by 19.62, how much? We will get around approximately 1.7146 meters of petrol. Okay, so difference of pressure head is 1.7146 meters. Okay, now we need P1 minus P2, difference of pressures at inlet and outlet. So we already discussed about relation between H and P1 P2. H is equals to P1 minus P2 by rho P into Z plus Z1 minus Z2. Using this formula we can find P1 minus P2. So now what is the value of H? H value is 1.7146 is equals to P1 minus P2 divided by rho P, density of petrol 780 into acceleration due to gravity 9.81. What is the value of Z1? 0 minus Z2 0.22 meters. Okay, let us simplify this expression. First transpose minus 0.22 to left hand side, negative becomes positive. 1.746 plus 0.22 is equal to P1 minus P2 by 780 into 9.81. So its value is approximately 7651.8. So 1.9396. So if you add these two, you will get 1.9396 is equal to P1 minus P2 by 7651.8. Now transpose this. Division becomes multiplication. 1.9396 into 7651.8 is equal to P1 minus P2. Just to multiply these two, you will get around 14841.43. So therefore P1 minus P2 how much? P1 minus P2 is equal to 14,841.43 Newton per meter square or pascals. Okay, so we need it in kilopascals for example. So P1 minus P2, difference of pressures at inlet and outlet is equals to, okay, divide 14,841.43 by 1000, okay, kPa. So therefore P1 minus P2 is equals to 14.85 approximately kilopascals. So this is the final answer.